Alright, what we're going to talk about here is something that we call the rate of change. Now this is a really important topic when it comes to writing our equations and looking at scenarios like that, because the rate of change is actually going to give us our coefficient. So this is a really important thing right here. Now, a couple things we have to know before we get started on our rate of change. We have to know that the rate of change, which I'm just going to refer to as the ROC, is equal to our delta y over delta x. Now before you know what that means also, you have to know that delta, or my triangle, equals the change in. That's all that means. So this is going to say what is the change in y and what is the change in x. And knowing these changes and putting them in this ratio right here is going to set us up to find, well, what is our constant rate of change. Okay, so what we have to do is we have to add some columns to the table that's already existed. And the reason I start with a table is because this is going to be the most common way that we find our rate of change. Because on a table you can really see our delta x and our delta y, or our change in x and our change in y. So what I want to look at is, okay, what was my change from 1 to 2? 1 to 2. Well, I added 1. From 2 to 3, added 1. From 3 to 4, added 1. Now, over here, my delta y, I subtracted 4, 8 to negative 12, I subtracted 4, negative 12 to negative 16, I subtracted 4. So to find my rate of change, I need to put my delta y over delta x. Now, since they're all the same this time, should be nice and simple. My change in y was negative 4. My change in x, so I had negative 4 for change in y, change in x was positive 1. Now I reduce this out. Negative 4 divided by positive 1 is just going to give me negative 4. This tells me that the rate of change in this situation is negative 4. Why that's important? Because that would tell me, if I was going to put this into equation, y equals, I need my coefficient times x. The rate of change is that coefficient. The rate of change is the number you multiply by. So this tells me, oh, here's my equation, or at least my starting point. I may need to figure out if I add or subtract something later. So let's take it up to the table right over here and let's test it out. 1 times negative 4, well, that gives me negative 4. 2 times negative 4, that gives me negative 8. 3 times negative 4, that gives me negative 12. And 4 times negative 4 gives me negative 16. So you can see there that by finding the rate of change, you can find the coefficient, or the number that you multiply by, just from that table. And it all comes down to the delta y over delta x. Now, let's look, say they didn't give you a table, but say you have something like this and you have a graph. Okay? Not a problem. We know from our multiple representations that I can turn a graph into a table just by looking at some coordinates. So I'm going to go ahead off to the side here, and I'm going to make my table with my x's and my y's, and I'm going to make a little coordinate section right here. I'm going to call it a coordinate right here. This is going to be my coordinate. So let's pick a couple points that plot on there. Well, immediately I see one right here that's 0, 0. So I'm going to put that on here, 0, 0. I also look down and I want to look exactly where it hits. It looks like I have one right here at positive 1, negative 4, right there. If I keep going down, I have another one that pops up right about there at 2, negative 8. And now, with just about 3 points is where I'd like to go, I can start making my table. So I'm going to put these right over here into the table that I already have. I'm going to have 0, 0, 1, negative 4, 2, negative 8. And now I'm ready to go ahead and find my rate of change. So let's look. My delta y, or my change in y, is minus 4 again. My delta x over here, if I'm looking down, well, that's going to be plus 1. This is going to be plus 1 as well. So now we remember rate of change is delta y over delta x. So to find this, I'm going to have negative 4 over 1, which is going to reduce down again to negative 4. That is my rate of change. If I was going to put this into an equation, this would be the number I multiplied by, negative 4x. Right there, the rate of change is your coefficient. Now, you may run into tables sometimes where your delta y and delta x aren't the same all the way down, but no matter what happens, you should be able to reduce them to the same thing. So say I was looking at a table over here, and I had something similar to what I had, and I had 0, 0, and then I had 1 to negative 4, but then say here I jumped to 4 and negative 16. Well, here my change is negative 12, and here my change is negative 4. My x's, my change is 1. Here my change is 3. If I reduce both of these, so I put, let's say, my delta y over delta x, if I reduce that, I'm going to come to negative 4. If I do my first one, negative 4 over 1, it's still going to get negative 4. So even if the changes aren't the same, like we have right here, you should still get the same rate of change if everything is working out the way it should. Okay? So there we go.